All right. So this is Class 5. Today is Tuesday, March 22nd. Got some bad news. We had our first casualty. Jim has dropped the class.
Oh, man.
Yeah. He said he didn't have time for it, and that's understandable. So we're going to go over the homework, but I guess I'll wait for Jeremiah. We just want to get some feedback from you guys in a minute and just see how we're doing, if we're going too fast, if you guys are having problems, do we need to slow down and go over stuff some more? But I'll wait till Jeremiah gets back for that. Let's go over the homework. So let me pull up that assignment. All right, so the assignment was to create an animal class. Animal was supposed to have 3 instance variables: description, is domestic, and weight. And we were not supposed to use the ATTR accessors for those, which means if we don't use ATTR accessor, then you have to create getters and setters if you want those values to be settable or gettable from outside the class. We could have left the getters and setters off. They're not a requirement. But if we didn't use them, or actually we did, I'm sorry. We used the getters, but not the setters. All right, so after that, we were supposed to create 3 classes that inherit from the animal class and set the properties of each one of those in their constructor. And then finally, in our main.rb file, we were supposed to create an array of animals and put each of the 3 we created in that array, loop through them, and print the properties of each. So some of you definitely had problems with this. Seems like inheritance was confusing. And that's okay. We're going to go over it some more. So just to start off, this is my animal class. So a few things you might notice here. There is no initialize method. That's not a requirement. Any class you create in Ruby does not explicitly need an initialize class. The only time we really need one is if we want to do something in that class. So if we want to have default values, for example.
That was actually
go
the
ahead.
thing that really screwed me up. Was
Oh,
the
really?
initialized method for a class.
Yeah, most of the examples we've done up to this point, we've taken advantage of using initializers to do certain things, but they're not required unless you need them to perform some kind of operation on setup.
All right, so every method you see here is a getter or a setter. So we've got get description, set description, get is domestic, set is domestic, get weight, and set weight. And you'll notice the et notation for our instance variables here. So again, these instance variables are not exposed to outside classes. In our main file over here, we couldn't call animal.description. That wouldn't work. We have to call animal get description. Does everybody see the difference between that and the ATTR accessor? Okay. All right, so let's take a look at, I created a class called alligator. That was one of my animals. So the first thing we have to do in this class is require or import our animal class, which we just looked at. Now, right off the bat, when we declare this alligator class, we say alligator inherits from animal. If we were to leave this off, alligator now, without inheriting, it has no access to anything in the animal class. It doesn't know that it is an animal, right? An alligator at this point is just an alligator. But now, when I inherit from animal, it's an animal. It's an animal first, it's an alligator second. All right. So we didn't create any any new functionality in our inherited classes here. So our alligator just has an initialize method, and in this method we just want to set those properties on animal. So that's what we're doing here. We do have access to it here.
So if you had access, you could literally write one more thing that it could do. It would still inherit from an animal, those 3 things that you're asking for, and then you can make it do something else. In this particular instance.
Yeah, so if we wanted to add something to the animal class, is that what you're saying?
No, back in the alligator.
If you want to add something special to just an alligator.
Just the alligator.
Oh, yeah, certainly. So
I don't know, color.
yeah, sure. Color equals green.
Those are my favorite alligators.
Now, that does not add a color to animal.
Right. Okay.
That is just on alligator.
And it's not trying to find add color or whatever. It's not trying to find color. The method. I don't know if I'm using the right method.
The method?
Yeah.
You're talking about like set color and get color or anything like
Yeah.
that?
It's not trying to find
Those don't exist on this class.
That's what I thought. Okay.
Now, color is a property that an alligator has. No other animals in this application have it.
Okay.
And right now it's internal to that class only because there's no getter or setter.
Awesome. Gotcha.
Yeah, so right now nothing has access to that color. We'd have no way of getting it outside of this class.
You need the at symbol?
Yes, otherwise it'd be local only within that method.
But it would still work. We could do
Yeah.
that. But it wouldn't even be accessible outside of this initialize method.
Okay, if you wanted to pull it or print it from the console.
Yeah, so if we left that at sign off, and then we had another method here called, we'll just call it get color. And we said we want to just return color. Well, that color hasn't been set, right? Because this is only scoped to our initialize method. But as soon as we add that at sign, that makes it an instance variable. And so now our get color would have access to it.
Cool.
Okay. All right. So the other animals were pretty much just like that. I had a dog. What else did I have?
The dog was my favorite.
A dog, an alligator, and a bear.
Okay.
And so, yeah, bear is pretty cool. So, this is my main class. And so what I've done here is I've required each of the 3 of my my dog, my alligator, and my bear classes. And remember, each one of these inherits from the animal class. All right. So when I say dog equals dog.new, oh, I'll go with alligator. So gator equals alligator.new. That calls this initialize method, right? And so these properties are going to be set. But what do these properties belong to?
The animal.
Right. They're part of the animal class. So here I'm creating an array of animals and just putting my dog, gator, and bear in there. And then this is my for loop. This is the last part of the assignment here. So when I say animals dot each do, that's going to iterate over each animal in this array. I here is my iterator. So that by naming this iterator, I'm able to gain access to whatever variable I'm on. So the first pass of this, I will be equal to dog. Second pass, I will be equal to gator. And third pass, I will be equal to bear. All right, so again, could I have done this? Dog dot description. Would that have worked?
No, I don't think so.
Why not?
Because I've tried it.
Because I tried it. It didn't work. All right, so
do you get why it doesn't work?
Calls a method that's not a real method.
There's not a method called description, right? That's the first problem. It's called get description, right? Remember, description is the property that's only visible inside of the instance of the object. We literally gave it those methods, get description, to expose some kind of interface that would allow people to get to that data.
So if he puts dog dot gets description, it still wouldn't pull it up though, correct?
Do I?
If he puts.
no, that would work. If I said puts dog, not God, dog dot get description, that would work fine.
Okay.
Because get description
Mhm.
is a method on the animal class.
Okay, gotcha.
Any
And
method that it has, all its children have.
You were just making the point that you didn't put the gets and it wouldn't pull it up, correct? That last example you were
Yeah.
yeah, gotcha.
but I don't want you to think that calling get description is like it only works because we named this method
Very well.
get description. If I had named this
Purple.
purple description, doesn't matter. Get description would no longer work. You don't get that for free or anything. Now,
It becomes standard.
some languages you do.
Oh.
Some languages, when you declare a property, it creates getters and setters behind the scenes for you.
Wow.
This is not one of those, as
Well,
far as I'm concerned.
it
As far as I
is.
know.
It is, but that's what ATTR accessory
Yeah.
stuff do for you.
Yeah, sorry.
But we're not doing that.
No, sir.
Not right now.
Is this on Bitbucket? This the home?
It is, yeah.
Okay.
Where was I? Okay, so
But you would have to type it out 3 times, and that's the whole purpose of this loop, is so that we won't have to type it out. Puts, get dog, get description.
Well, he wouldn't have to just do that. He'd have to do that whole logical bit down inside the loop.
The if else. Okay.
Yeah, I think he's about to talk about that.
yeah, so since I am iterating through this array here, basically you could, the first time through here, we could just replace, I don't want to say that. Let's just kind of run through this in our head, right? So, again, the first time through, what is I equal to?
Dog.
Dog. So puts, what's that? What's I?
Dog.
Dog dot get description. What is that going to print out?
The description of the dog.
Correct. Okay, so if I, which is equal to
Dog.
dot get is domestic, that's going to return what? Let me open my dog class. So is domestic on dog is set to true. So back in main, if dog dot get is domestic, what's going to be the output from this block of code here?
I am domestic.
Correct. I am domestic because dog, again, is domestic is set to true.
So you don't have to define it right there that it's true. If it's true, then print this. If else false, print this. It's implied.
Well, no, it's not implied because we said it explicitly here. Right?
His if statement is inside the loop, though. It's outside of the object. See, go back to your main. See, that's where he's doing the if dog dot get is domestic, print one thing, otherwise print another thing.
But it doesn't say if domestic is true.
Okay, I see what you're saying. So this statement here,
Mm-hmm.
I dot get domestic, what does that return? Get is domestic. That returns,
What you put underneath the
True.
well, in the case of dog, it returns true. But what is domestic?
It's under animal class.
Okay.
It's a Boolean.
It's a Boolean.
Oh.
A Boolean is a data
True or
type
false.
that is either true or false, right? So this statement is going to evaluate to either true or false. So I could have said if I.get is domestic is equal to true, and maybe that reads better, but it's not necessary.
True always evaluates to true.
Mm-hmm.
So
True
it's
that.
implied.
Yes, sorry, I didn't understand what you were asking. So yeah, we do that to just save time and space and energy, I guess.
Programmers are lazy.
And if you gotta work with all this,
Alright. Okay, so now that line is executed. We get to puts I weigh what? I.get weight is going to be what?
whatever weight is from the animal. 10 from the dog.
Right. We're still on dog here. So I weigh 10 pounds. So we print it out. All right. So the next iteration of this, what is I going to be equal to?
Alligator.
Gator.
Gator. Correct. So I.get description or Gator.get description will return I'm an alligator. I.get is domestic will return what?
I'm wild.
Correct. I am wild. Unless you're crazy and have a pet alligator. Which some people do.
Like 40 pounds, maybe 5 pounds.
Yeah. And finally, it'll print I weigh 200 pounds. All right, so the last time through here, what is I going to be equal to?
Maybe.
Fire.
Bar. And get description will print, I don't have that open, but it says I'm a bear. Is domestic, I'll probably guess it's not domestic. It's going to print I am wild. That's pretty much it. That's really, that meets all the requirements of the assignment, which I'll open up one more time here.
Oh, dang.
So, create an animal class. I did that, right? This is my animal class. Create 3 classes that inherit from my animal class. That's alligator, dog, and bear. In the constructor of each one of those classes, set the properties that are inherited from the animal class. That's what we see here. And then finally in the domain.rb, create an array of animals, loop through them, and print the properties of each. So that's what we're doing here. Now, I did want to show you that, go ahead, you have a question?
Yeah, I followed along, and I'm not, when I did the rerun, I'm still getting, what does it say? I'm getting I am wild on all of them when I had the blah, blah, blah. The dog is true.
The bird is mine.
True.
This was so much more simpler than what I was trying to do. I was trying to do something way more complicated.
Yeah.
Because I don't think I understood what I was doing, but I'm going to go through that and then try to apply to what I was doing.
Yeah, and like I said, this is already up on the repo. If you just pull it down, it's under assignments. Assignment 3, I think it was.
Because I think one of the things that screwed me over really bad was I put an initialized thing in the animal class.
Yeah, and so I saw a lot of you in your animal class, you had initialized, which you don't need, but you're also passing in arguments here. So
yeah, that's what I did too. And that screwed me bad too.
yeah, so you know your initialized class does not require any arguments ever. You don't have to have them.
Okay.
Let's see. So another thing I saw a lot of you do was create a zoo, which is pretty much what our main RB class was here. You could think of our animals array as a zoo. I was gonna add that to the assignment. I just decided to not do it at the last minute. It was good to see y'all thinking that way.
So if you needed, like, if you did have a pet alligator,
Mm-hmm.
you would make a new variable called Charles equals alligator new, and then set the, whatever it is.
Yeah, we could totally
set
do that.
as domestic to true.
Yeah.
Mm-hmm.
Oh, then you have 2 alligators. One's domestic, one's not.
So yeah, I'm glad you said that. So Gator by default, right? When we knew it up, because in our initialize method we're setting is domestic to false. That's the default value. So we'll do exactly what you said. We'll create a new Gator.
I like that name for an alligator.
Distinguished name.
And what are we going to call?
He's got a monocle.
What are we going to call to change that?
Say that again.
What are we going to call to change the domestic property?
Set description.
Get is domestic.
Both wrong.
Set is domestic.
Right, because we're trying to set the domestic property, right? You guys are proving that even a broken clock is wrong. Or right twice a day. All right. Set. I forget what I called it.
Is domestic.
See, it's
Okay.
hard to remember.
Set is domestic equals true. So now, what?
It's a method, not a
Oh,
property.
sorry. You're absolutely right. What would I do without you? Okay, so we'll pass true to this method. Set is domestic.
I wouldn't. It gave me an error, and I'd be like, huh?
Well, we'll give yeah. Did I give you an error?
Yeah, it will give you an error.
Okay, let's run it and see what the error is.
Method does not exist.
Explosion.
Undefined.
And it also asks you, is that what you meant?
Yeah, so that's a pretty good error message, right?
Except like you said on the thing, it doesn't tell you how to fix it.
Actually, you kind of did. Look at the
Yeah.
next line of the error. Did you mean
Did you
set
mean-
is domestic?
Yeah, but it doesn't.
It still says, it doesn't really explain
It
the
didn't tell me to
problem.
take out the equal sign.
It's a method though, not a property. You can't set a method equal to anything.
Mm-hmm.
Okay.
All right. So, set is domestic is a method. Again, we're going to call that and pass it true. So now let's throw Charles into our array here and run this again. So Charles is the last one in the list here. He's an alligator. And he is domestic.
He's a fancy alligator.
Yeah, he is.
I think he's faking it.
Set his description to say I'm Charles.
I am
Yeah,
going
fair
to.
enough.
It's just the input.
If I want to do that, what do I do?
Charles dot set underscore description. No equal sign. String I am Charles.
Oh, I could dance.
Really back to the talking alligator named Charles.
I am Charles. I am domestic. I weigh 200 pounds.
Probably should put something to stop that.
Probably.
He's 7 foot tall.
All right, so I went back to my alligator class, and I added this property called color, right? And I set it to green. Now, I want to, not in my loop here, but I want to print that out from my main class. Who can tell me what I need to do?
Oh, is that the get string at color? I meant gets.
What?
No. No.
GTS, and then pull the instance of the at color.
Okay, remember you've got an object here, okay, that has some attribute in it called color. We want to access it from outside in here somewhere, but we can't just reach in and grab it, can we? So we need something to interact with it.
Well, it's under the alligator class first. Wouldn't you have to say something alligator put?
It's already set. We've set the color on this
The
alligator.
color is equal, so we need.
Don't we have to do it under main?
No, right now we can't do it under main.
And
Self?
no,
I can't see.
The
You
DEF.
can't define it under main? Set.
Okay.
Set
Def
color.
at color?
No,
And you put
we can
or
define it
set
on
color.
animal.
I don't know.
Why?
Get color.
Is that what you meant?
Say that louder. So
Def get color.
Do we need to add a color method in the animal or no?
Just to that.
Right,
alligator.
right now, alligator is the only thing that has our color property.
So def get color dot alligator or whatever underscore alligator.
let's take it one step at a time.
Okay.
So we don't
D.
go under animal.
D.
and do-
We could.
Okay.
What I'm trying to do is give alligator its own unique property. We just happen to call it color, which obviously every animal would have that same property. But just for this example, I want alligator to be the only class to have this. Okay?
And you want to be able to pull it.
And I want to be able to get it from the alligator. So you were close, David. Sort of. We need to create a method, right, to pull this property out. What is our property called?
Get color.
That would be our method.
Oh, sorry.
You're right. We're going to call it get color. And it's going to return the value of
Color. So at color.
color. Alright.
You need to set it.
Do you have? Yeah, I was going to ask you.
You don't have to give it set unless you ever want to be able to change it.
Have a brown one.
Well.
Have a brown alligator or a black alligator or a white alligator?
It's not a
Yeah,
perfect
black
world.
alligators pretty good. From what I
Right, it's not a competition of color on the alligator.
Poor Charles.
Yeah, poor Charles.
Charles the albino alligator.
He's green.
He's green, man.
They're all green.
They had they had an alligator like that outside for once. Pretty cool.
Charles dot get color.
In living color.
In living color. What is that? What is that going to print out?
Green in color.
Charles is green in color.
Thanks for trying to run.
And it did. Charles is green in color.
Why did you? I'm sorry. I'm trying to make sure that I see that. Why you need the Charles dot get color?
Right here?
Yeah.
Well, because how else is it going to know what object you're asking for its color from?
Well, the reason I thought we just talked about is that it was because it was only under Gator.
It is only an alligator, and Charles is an alligator, right? But
Oh,
we're
so you're
not,
just kind of
we're-
bouncing. Okay.
We're not inside that class, are we?
Very well. Okay.
Let's rename our bear to Bobo.
Yeah.
What about blue?
So we want to know what color Bobo is, right? That's Bob.
That's close.
Did I miss any?
No, you're good.
Okay. So is that going to work? Can I say
No.
Bobo is?
No.
Why not?
You haven't specified.
Yeah, change Bobo's.
Bear class yet. Or, yeah.
Right? Bobo is a bear.
You
And
didn't
bear
Never defined that though.
doesn't have a color property, right?
Yes, and also property.
And also what?
Also doesn't have a color property.
Yeah, so he doesn't have that method, and he doesn't have a color property. So that's going to crash.
So having the at color will not do anything unless you define to get the color when you want.
It does something.
I'm sorry, it won't print out. It's a big
Well,
one.
we can't get to it from outside of the object.
How would you get to it from inside the object?
You refer to it as at colors.
Just like we're okay.
Yeah.
So let's start adding this to bear, right? We want to say color equals brown.
Well, that.
Now,
What kind of bear is it?
it's a brown bear.
I wonder.
It's a polar bear.
Should be a black. Should be a black bear. Come on.
All right, so if I run this, what's going to happen, David?
Nothing.
Nothing's
Well,
going to happen. Something's going to happen.
color.
We don't have the method yet.
We didn't ask it to get it.
I did ask you to get it.
You did.
In Maine, I said Bobo is.
Well, you still don't have
You
the
didn't
method specified.
Asking the
I do
object to perform an action does not necessarily mean the object can perform the action, is the point he's making. It's just going to error out.
Yeah.
But it doesn't have a method specifically for the bear class to
Right.
get the color.
Correct.
And you could do it A here or B in your animal under,
Oh.
but you would have to do that for every animal if you did it there. And I don't want to confuse, correct? Without confusing them.
Well, let's add color to animal.
There we go. Okay.
Okay.
It doesn't confuse it if they're two completely different classes. Do you mean if one inherits from the other?
Yeah.
Okay. If I have a class A.
I can't see the marker on the board.
Oh, jeez.
Are you using that? Oh, okay.
No, it's just dark.
Good.
Okay.
Stupid.
Follow me in your head. If you have a class A, it's got a method called calculate on it. All right, we've got it filled in, it does some logic. We also have a class B. Class B inherits from A.
Alright.
So it gets that calculate method, right?
Yes.
If we define it again and give it new logic, we overwrote the old calculate method.
So
We
it'll
replaced it.
So it'll automatically go to the one that's closest to the file?
Right, it'll go to the one that's closest to that class. So it completely overwrites parent methods. It actually fully replaces them.
Just kind of wasted code.
It's not wasted code. You sometimes want to do that.
Oh, okay.
Yeah.
Sometimes you want to just edit a specific thing about, like you want to have just a generic group of something, but you want to have a specific variable in each of them.
Yeah, sometimes you might want a class that inherits from a base class to have different behavior because it is more specific, right? All right, so I just added get color and set color to my animal class, and I reran my program. And so now instead of an error, I actually get Bobo is brown in color. Does that make sense, everyone? Does that?
Did you still have Bobo if you go to your bear class right now? I mean bear file? You didn't. Okay, I just didn't know if you. Gotcha.
Yeah, still set using this. Now we could get rid of this. What do you think is going to happen now?
It won't tell you anything about a color.
You think it's going to error? And you think it's going to say nothing about the color? So Bobo doesn't have a color, right? Color in Bobo's instance is what? It's
Nil.
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 That's right. Because it hasn't been set by anything. But since we created those methods on our animal class, we could say Bobo set color and set it to brown here. So now when we run this again, he's brown again. Everybody follow?
Starting to click.
It's doing it over and over. It's repetitive.
This is very repetitive stuff, and you just got to do it over and over and over until the concept kind of clicks.
Yeah, that's what I meant. It's like playing Call of Duty or something. You don't get it right off the bat.
You got to get killed a lot.
You do,
Before-
man. Then you know how to quick scope and everything's good. 360 stuff. I'm just kidding. I'm not that good.
All right. So, are there any questions? Any more questions on this assignment? No. All right. So, Jeremiah, I wanted to wait till you were back in here to ask him those questions. So, you'll notice I have. Damn it. I was gonna say you'll notice I only have one tab open, and then I pull it up and there's a million tabs open.
Well, less than last time.
There's my one tab window.
You tried to cheat.
It's not cheating. All right. I lost my place. What happened?
I don't think that's the right font.
Gentlemen, really quick, what was the point of using the Apple? Just for the user friendliness of it, the Mac?
The purpose for using it was because Cohab had a bunch of them already.
Very well.
But no, Ruby typically runs smoother on a Unix-based machine than it does Windows. It can run on Windows. In fact, he's running it on Windows, but it typically lags a couple of versions behind, and there are certain gems that refuse to ever run on Windows. They will not work on Windows. The people who make the gems will not support Windows. And so we won't be using those. I don't think we'll be using any of those in this class. But yeah, Linux and Mac have always been a little bit more friendly with open source software solutions, which is what Ruby is.
All right. So, like I said before, we really want to get some feedback from you guys. We want to make sure the pace that we've set here is okay. See if you guys need more out of it. So first question here, how much time are you spending outside of the classroom? So let's just go around the room real quick. Start with you, David. So far.
Like the whole week or in classes?
Week to week.
Yeah.
Probably like 4 hours at this point.
4.
Roughly.
I'll turn this on.
Navy Davy.
You can be honest. It's not.
I'm
We're not
trying
gonna
to
harm
think.
one
Yeah, no,
anybody.
seriously,
It's-
10, like about 2 hours a day during the weekday, roughly.
All right. Nick.
I would suppose like for the whole week it would probably be 7 to 8 hours.
Are these including class time or
Oh, not including class time.
not including? Okay.
It says
Mine
outside,
is.
because it said outside.
Yours is.
Yeah, my bad.
I knew the answer for yours, but
Well, yours is 4 hours.
Here for at least 6.
There's 6. About you, Ben.
I'd say I spend a lot of, I can say during downtime in classes and classes that we don't actually do anything in, is usually when I just pull out my computer, start making useless programs that will just do like a one-trick pony and be done with it. And maybe a little bit at home. So I'd take it around maybe 5 hours a week.
Okay. Deborah.
About 8.
8. Christy.
Not enough.
Not enough?
Probably 2-3 hours. Just the last couple weeks has been.
it happens.
Oh yeah.
We're just trying to get an idea for
Yeah, we're not.
what we need to do.
Wednesday homework.
But this is also not just looking at what you guys put up, or what we, but kind of what we talked about, and then looking at different
This
files.
is looking at anything. Looking
Yeah.
at what we put up. Looking at other material.
Okay. Playing the zombies thing.
Yeah.
Yeah.
Zombie for real.
Yeah.
I've done that. Code Academy, I've done that.
All right, so we put this question down twice, just to kind of reiterate that it does take a lot of outside work, and again, we do understand if you can't commit as much as everyone else, it's hard for us to commit as much time to this class as we want. So yeah, but we said on the first day, if you're not putting in the effort, this is going to be much harder to grasp. If you're not, and if you are having problems, please feel free to send us questions, sooner rather than later.
Or ask us if you want to meet before class. We don't leave the building usually between when we get off work and when class starts. So if anybody ever needs to meet to work some issues out there with the homework or anything like that, just reach out to one of us on Slack, ask us if we can meet you, and we'll set up some time.
Lord knows I've asked John's.
And seriously, don't feel bad about it. That's what we're there for.
Yeah.
I was about to ask you, like, man, I'm sorry for bothering John. Like, Jeremiah, I need to.
All right, so what resources have you guys found to help you when you do have questions, or what resources have you found that are just helpful in general outside of the
Outside of
videos
class.
or class?
Google. Yeah, well, just Googling things and looking at examples and stuff. There's sometimes though they show you different versions of things, and that can be a little bit confusing.
Mhm.
But
In Ruby, there's about 100 different ways to do the same thing.
yeah,
Yeah, you'll probably even notice Jeremiah and I have different
and then it's like, well,
coding
how
styles.
do I make this work with what you guys showed me?
Mhm.
You'll pick up on how to do all that over time. It'll get easier after we start talking a little bit more about in-depth object-oriented programming and how to plug into different things. But
You guys said Code Academy. How you use that?
Code Academy,
Khan Academy.
Khan Academy is one.
K-
Khan Academy does
H-
training
A-
too.
Code School's one.
Code School.
Yeah.
I would recommend Ruby Cones.
Ruby
Stack
Code.
Overflow.
Let me check.
Yeah, Stack Overflow is a great resource for specific questions.
Cones is Koans. Ruby Cones, Koans.
I just have some Ruby books that I've
Oh, you do? Okay.
I use the guide, the Rails guides.
Mm-hmm.
Learn Ruby the hard way.
Yeah. I was
The
looking at
hard
that.
way. Oh, thanks.
I got, there's one, and you please tell me if it's valuable. Ruby, -4 beginners. It's, Ruby Monstas, spelled MONSTAS.org. RubyMonstas.org.
Monsters.
It's got a little book on there, and I was gonna ask y'all about that, whether or not it was up to date, because it doesn't really.
I can't think of the name right now, but it's like a game, and the game is, when he said monsters, I think it's like a zombie
The
game.
zombie Rails for zombies.
Yeah.
Yeah.
Yeah. Rails for Zombies is a pretty decent tutorial setup. The issue with a lot of those bigger named ones is that they kind of assume you already have some kind of grasp on the fundamentals, which is why we're talking more about the fundamentals right now than we are Ruby or Rails. After probably a couple more weeks, we're going to start diving into more specific stuff with Ruby and Rails. But if you don't have these foundations and you don't understand the language that they're trying to tell you, sometimes it can go over your head and then you just get frustrated. I know I did.
All right. Is there anything we've gone over in class, any concepts we've introduced that you just don't understand, that we need to spend more time on?
We can use this feedback to build better exercises to
Yeah.
The only
come back up
time
with
I've
stuff,
really
so.
been seriously stumped with this homework exercise, but you guys went over it, so I kind of cleared that up for me. So
Joe, we're not going to be leaving inheritance anywhere. It's going to be showing up again and again and again. So
The self, and I got more of an idea of it. But the self
we'll be back to self.
always, it was just, but never mind. I think I've got a better grasp of it obviously than I did when we first started. But
We're going to talk a little bit about what self does today. So
I didn't understand the assessor, but now I do from last class.
okay.
For me, it's when I'm in class, I can understand it, but when I get ready to apply it, that's where I kind of,
The theory
stumble
starts to
along.
click, but in practice, it's harder to connect the dots. Yeah, that's just going to be repetition.
well, it really helps to go back and look at the examples and stuff, the classic assignments,
Yeah.
because when you go through it and you knows what it does, you can kind of infer.
Well, if you notice the trend too, kind of that we're trying to get started here, is we're trying to make it to where we're doing less and less theoretical lecture and more you're coding along with us. That's going to be helpful too, because at least you put your hands on something.
Mm-hmm.
It was helpful today, just when you were talking about the example, going through how things flow.
Mm-hmm.
That was
So just like stepping through execution
yes.
line by line.
what brings what to where? That yeah. Because saying it's a method, I deem a method as this, and DEF as a definition, I'm thinking literal, boom, as in a dictionary. And then, so I'm just trying to make sure that it all, because our brains have been taught this, and this, and it's like, oh, that
You haven't
this.
formed all these mental models yet
Right.
of these things. So.
But when we first did that first homework, that first weekend, that Thursday, it took me a while, I was stumped. And then I got on one and said, boom, all right, my first code, it's a palindrome, look, it's awesome. And then the rest of it started going, look,
Yeah.
and then I got stuck in the last one. I was like, oh crap. Because I had to take a break, and like I was telling you, once my mind was going, I was like, oh, this is cool. Like she said, you could apply it, and then if you're just not used to it, I couldn't just jump back on the horse that fast.
Yeah.
But you guys going over it and saying, this pulls this, makes it make a lot more sense.
Okay.
And lastly, has anyone done any unassigned examples? Ben, you said you've been writing little one-off programs.
Yeah.
We're curious. We're just curious to know, what you do with it in your free time. I guess, like, what kind of stuff have you been writing?
Just been standard, your generic number guessers to doing your algebra homework for you.
Nice.
Yeah. Studying with numbers and stuff.
Anybody else?
During one of the assignments, there was something to do with like a birthday. I tried to figure out how to make it take
We'll be revisiting dates the closer we get to Rails because there's an actual date object, just like there's a string object that you can use to format dates and stuff like that pretty easily. So.
I think, I can't remember which one, but I took, it was like one of the first homeworks, but I blocked it out with the begins and the end. Just was playing with that, which is something I saw with the 5 times dot do before we ever got to that, just to make it loop.
Mhm.
I was like, oh, that's cool, because it's so simple there. But
It's so easy to do.
when I see that I, that threw me for a loop.
Threw you for a loop.
I wanted to ask you, on the end, you had that, slash in, that was an escape character?
Yes, ma'am. That is that's the carriage return or
New
line
line.
break, new line.
New line is \n. Different languages and different systems require different characters to go to the new line. A carriage return traditionally is \r. You don't see that a lot of places outside of C nowadays, though. Most of the time, the new line character /n will do that for you.
You used to have to do both, right?
Hmm?
You
used to have to do both, yeah.
Yeah. All right. Okay. Well, we'll probably ask you these same questions again in like 2 weeks. We want to get feedback as we go.
Is there a good book that I can look for that kind of?
I own literally this many books on modern languages. And the reason why is because by the time they get published, they're usually out of date.
It doesn't make sense to own something that's static when
They go through such a long editing process that by the time, and in fact, I've heard arguments from a lot of people in the Ruby community because Ruby's updated about once a month. And how do you publish a book about a different version of Ruby in that amount of time? So they do have a lecture series and an example series that they keep up to date themselves. But as far as books go, they tend to lean more on keeping forum posts up to date because they don't have to go through an editorial process.
So where online can I mean,
That was one reason why we asked these questions. We wanted to see what people were already using, and then we're going to make some recommendations on some good resources outside of class, because first of all, we want you to spend the time outside of class. Second of all, we want you to spend quality time. You know what I mean? we don't want you looking at the.
If you're looking at an old source, I'm like, oh crap.
Yeah.
In fact, one of the books I have, he directs people that are reading the book to a website where they're up there.
Yeah.
Yeah.
That Ruby's .docs, the up-to-date one, right?
Yeah.
Or Ruby-docs. Or
Yeah,
anyways,
the doc site.
the doc site is a little still, I guess it's overwhelming for me too, because I was trying to, y'all were saying, go
Well,
there and
it's
check
not
it.
it's not really a learning tool either. It's a reference tool.
Oh, okay.
You know, if you're looking for if you've got a string and you're like, before I write a method that does this for me, let me see if one already exists on a string class. And you can go look for it and search the documentation to see if one's there. That's kind of what that's for.
Okay. For those that have a good understanding and just trying to find a better way to do it, as opposed to somebody new.
Yeah.
Okay.
Because a lot of that stuff that you see in there will confuse you if you just try to go read it. You know.
It'll say toggle here for source, and I click on it. That's even more
why is
confusing.
this colon here?
All right. Are there any more feedback or questions or anything?
I think for y'all's first time, y'all are doing a pretty good job. All I could think about was, and I'm not going to be serious, but spending $2,000 to learn something that will better me. Hopefully, because that was the goal, was possibility of changing jobs later on, becoming an intern, whatever, starting at the bottom, working my way up. Because this oil business is just crazy right now. So
Yeah.
I just want to have a better understanding. I want to be able to help friends. I got friends that have side businesses, and if I can help them and create a website for them, and just pro bono, yeah, and make sure that I just say, hey man, don't hold me accountable. It's my first try. No, get better at it. I really want to do that. I love playing with computers, and why not get it to help make me money?
Yeah, I understand that.
All right. You wanna?
All right, ready to
Start.
jump in the deep end?
Yeah.
Okay.
Actually, I'm gonna grab.
All right. So, one of the reasons we brought this up too is, and we want to try to give you all some good examples and stuff like that, good reading material to study on your own, is because we have to start spending a little bit less time going over homework. So outside of class, before class, if y'all need help, definitely come to us. But as you can see, we've already eaten up an hour of the class time. We haven't gotten any material yet. So, but we'll work on that. And all right.
Do you have
Notes
office
here.
hours per se
Uh,
that we can hit y'all up without being annoying?
if it's on Slack, hit us up anytime. If we're available, we'll respond. If we're not, we'll get back to you when we are. If you need a face-to-face meeting, this week's bad for me. But next week, anytime after work usually is okay, as long as I'm not teaching some class on Tuesday, Thursday nights. But other than that, yeah, I'm pretty flexible.
John and I use that team viewer. I don't know if anybody
Mhm.
else has used it with you or whatever.
I used it with him.
Mm-hmm.
And that helped a lot. Because committing still got me jacked up a little bit, but I'll get better.
All right.
What was your problem?
Some nonsense.
I did get a code that the other day. It was really cool.
Okay. I think I'm going to start by talking about pointers a little bit. All right. So, generally speaking, is it easier for people to see this board or that board?
I'm sit like the dead center in the back, so I'm just kind of chill.
Okay. All right.
I'm good. It 6 in 1 hand.
I can't see it at all.
You don't matter.
Awesome.
Okay. We talked a little bit last week about how memory was stored, okay, as far as integers go. And talked a little bit today about how memory works when it's running in the application. Because I feel like that will help clear up two potentially confusing areas. One, scope, because some of us are still struggling a little bit with that in certain areas. And two, self will sooner become readily apparent if we talk about it now rather than later. If this is a little confusing, that's okay. I just don't want to completely lose you, so let me know if we start to get to that point. Alright, so there's two things we need to talk about with regards to application runtime. Alright, and the application running stores memory in two different places. You've probably heard of one before, just from seeing errors on Windows, and you probably haven't heard of the other. One's called, and this is the one you probably have heard of, is the runtime stack. Okay? You'll see stack overflow exception or something like that, runtime stack died, something like that. The other one's called the heap. Alright? Now, when we talk about the stack, we literally mean a stack. So, we have a bunch of blocks. They're built up like this, and it's a stack. You can't pull things out from the middle. You can't pull things off the bottom. You have to put things on the top and take stuff off the top. If you want to take this guy off, you have to take off all three of them. Okay? Now, the other guy is the heap. Alright? We're not going to talk about what the heap looks like, because it's confusing. But just know that memory can exist in either of these locations. Alright? Now, the reason why I want to talk about this with regards to scope first is because that hopefully will explain most of this without having to discuss the heap really. Okay? So, when the runtime stack starts going, your application starts. Code is being run. Now, for memory, we think of it like last week, maybe a variable x, that's an integer, all right? And maybe it has a value of like 52 or something like that, okay? Let's say this is not an instance variable. Let's say this is inside of a method somewhere, all right? So if we're reading this line by line, things are being put on top of the stack, right? So this is something, some area of code that's been executing, all right? And we start to execute our method. Doesn't matter what it's called. I'll just write DEF here so we know this method started, all right? That line literally runs, okay? It has a block here. It assigns some variable x equal to 52. And when I say it assigns x to 52, I mean it literally does this without the at sign, without self dot, anything like that, okay? So this value 52 is scoped to this method, isn't it? If this guy is wrapped inside of a method called whatever, okay? When this method ends, this guy no longer exists. This is why this happens. When the end of the method comes up on the runtime stack, okay? Where's the rack? So let's say these executed one at a time, okay? That got put on, that got put on, that got put on. When the end reaches the runtime stack and is processed, it pops off everything back to the start of that method. It's done. It doesn't need it on the runtime stack anymore. So when this chain closes and says, I'm ready to close this method out, we're done with this execution. Because you can't cut just def and end out and leave the variable. X gets taken with it. That's why if I had x here and I had another method here, x doesn't exist here, does it? Not unless I set it equal to something, but then it's another local variable. All right, well, let's take this a step further, okay? In the middle of a program here, okay? Now I'm writing, maybe I shouldn't write class, maybe I should write object, because objects are what interact at runtime, right, not classes. So this is an object that contains the variable x, all right? So this is kind of the beginning of this, right? I'm just going to call it class P. Let's say we're back in our person. I'm just going to say P because I'm going to get tired of writing person so often. All right. So this is an object of type P, okay? Type person. It has instance variables of anything we gave P, right? So let's say P had a name, all right? So when this object gets on here, one of the things that's assigned, let's say we had an initializer defined, okay? And we set a default name. Maybe we set it to unknown or John Doe, something like that. Something that makes sense. Either way, we have an @ name that's been defined, right? Okay, everybody with me? All right. Now let's say we ran a method. We call the method. We're inside of that method scope now. Now, if I made a variable called name inside of this method, okay? Because he's not here today.
Is it Jim?
It is Jim.
Okay. Okay.
Yeah. In our hearts. Okay. So I made a variable here. Well, here I set this guy equal to, well, what did I say? unknown or something.
Mm-hmm.
Okay. Here, I set it equal to Jim. So the value at this memory location is Jim. Alright? Now, when I set that value, it didn't set this value, did it? It set that one. It's locally scoped to that method. Now, what's happening here is, I'm going to try not to block anybody. We have a memory address, okay? Some series of numbers, okay? That's where this value is located, all right? This right here, this guy, points to this value, okay? It's called a pointer, right? It literally, this is the actual value that is stored inside of here. And this address points somewhere else in memory where this value is being kept. Okay? Now, if I say at name equals something, that's saying, oh, I want to set the value at this memory location equal to this. We have variables so that we don't have to set memory addresses equal to something. Okay? They're placeholders for us. They're to help us. All right? Programs don't need them. That gets confusing. Now, what about this guy? This isn't at name, right? This is local name. It has a different memory address. Okay? It's pointing at a different location. So if I set this equal to Jim, the value, my instance variable name, didn't change, did it? Right?
Right.
Okay. So when end comes up here, what happens?
It gets rid of it.
That guy gets chopped off, right? Now my @ sign name does not, but that method that was running is gone, okay? Along with the scope and all the memory it had to allocate to perform its job, okay? Now, when we're talking about pointers, where they're pointing to, most of the time in Ruby, not all the time, most of the time, when objects are pointing at something, or our variables are pointing at something, they're pointing somewhere in the heap. Okay. And so this memory address that this runtime stack has, it's over here. Okay? The reason is it would be really hard for us to set this somewhere safely inside the runtime stack, right? Because it's constantly having stuff popped off and on and stuff like that. As long as we keep a reference to this area in memory, this guy never has to move. Right? So, self. Alright? Who has a general idea of what they think self is?
So look, going off what you've done here, it refers back to an object.
Oh, snap! When you call self,
Was that excitement or?
that was excitement. When you call self inside of one of these methods, you're referring back to this guy.
That's always and forever.
So it's just a shortcut for
It's a
referring
shortcut
back to the
to refer back to myself.
with the object that you're
Right.
currently.
So you can only access self from inside the object. So
Yes.
self is different for different instances of objects.
That's why you can have multiple cells in.
You can have multiple instances of the same class.
Can you have a class self? Would self be inside of a class?
Well, so self, if you call self inside here, that's what we're talking about. Okay, that is inside of a class, but classes don't interact here,
Okay.
right? Classes turn into objects. Classes are instantiated into objects, and that's what runs here.
Okay.
So self literally comes back and points to this object, doesn't it? So when I do that and I say self.name, what is it doing? Like, let's say we have that ATTR accessor. Okay. So we're in class P here. Alright, that's the syntax that we've been leaving out for a while, right? We told you last time what it did is this actually unfolds and it makes a couple of methods, right? It makes getters and setters for you. So we have a name, which just returns that property value, right? And then we have a name equals. And that's what allows you to do that equal sign thing, by the way, that equal sign is on it. And that sets this guy equal to value. So if I have some other method called compute, I don't know what person would be computing, but I said name equals Jim, just like we did over there, okay? This is the local variable Jim, right? That's not the same as our @name, right? That this guy gives us. These guys are generated by this. We don't have to put these here. Imagine these are commented out, alright?
Those are your getter and setter right there?
Yep.
Okay.
So if I say name is equal to this, that doesn't give me anything, right? I didn't just change this value, I set a local variable name. But if I say self.name equals Jim, that's different. We already said self refers back to the object, right? Then I'm calling a method on that object, which is this guy, name, equals the value that I'm passing in. This guy sets my property value. That's why self.name can change that value on the instance level, and setting name equal to that can't. Okay? These two right here logically are equivalent, but only because you had this guy in here to generate this method for you. But self is used a lot, not just with ATTR accessor and stuff like that. Some people use it all the time just to be explicit. Hey, I'm calling a method right now. Okay, it's one easy way of telling the difference between a variable inside of the scope of a method and another method, right? Because if I had another method in here somewhere,
It wouldn't pull against something, is what you're saying, they just use that as a,
right?
okay.
Yeah.
It wouldn't pull an object, they would just use it to say, here's another method. I see
Right.
what you're saying.
So that in essence is what self is. You know, that is the explicit, real down to earth explanation of what self is. It is a pointer referring to itself. Does that make sense?
Mm-hmm.
That went way smooth. I almost feel like that went suspiciously smooth.
Right.
It goes back to
This
the first
really
time
makes
you used
sense.
itself.
It's probably because Jim's not here.
Yeah.
I'm just kidding. I'm just kidding. Sorry, Jim.
That's actually really awesome.
I'm gonna make him watch this video.
This is Brad talking.
Yeah.
Alright, so staying with the concept of pointers and memory just for a second, okay? We know I'm going to keep things we're just gonna talk about pointers in general now. We're not gonna talk about allocating on the runtime stack or the heap, because Ruby handles that for you. You don't have to worry about that. It knows where it's putting stuff, so.
Really quickly, so we do Ruby main.rb. It runs our program, it executes everything, whether it's in the heap or it's in the stack, and then it's gone. And
Heap, yeah, yes and no. We'll say that, but because the runtime stack literally will pop on and pop off values that it wants to get rid of quickly. The heap, you can actually make the decision of leaving something in the heap for the entire length of the application's run.
awesome, okay.
But we'll talk about why that is a little bit later.
That's how that.
Okay. Anyway, so let's talk about, let's stay with pointers, but let's talk about your animals example that y'all did. Okay? So we had Bobo.
Over the bear, he's back.
All right. Who else did we have?
Charles.
Charles, the
He's in
alligator.
charge.
You didn't name your dog.
No.
Buster.
Buster.
Such a
good
cliche.
dog. That's a good dog name.
Such a cliche.
Jim.
All right. So this is.
You don't let Jim kick.
I know,
you.
right? Jim's a dog.
Can't forget him.
All right. So this is my array, right? Okay. Well, these aren't flat integers or flat floats or anything like that. That's really linear to store, are they? They're all objects in and of their own right. They have pointers and everything like that inside of them, pointing to things in the heap and everywhere else, right? I mean, it's this. If we follow this tree, we could end up with a real spider web here. So we're not going to do that. But it's important to know that when we have these variables here, each of these are pointers. How many of you, when you were trying to print out the different animals that you instantiated, did puts Bobo or something like that? And what you got out was like a, I don't know, animal colon 0x00879.
I've seen that
Yada,
before.
yada, yada. Okay. Guess what that is?
A memory
That's-
location.
That's Bobo.
That's the pointer. You just printed out literally that pointer. That's the address in memory where that object lives. Okay? So if we follow that trail out to the object somewhere, these things don't actually have to be side by side like they are in the array. They could be anywhere else in memory. Okay? But we can still sort them. We can still analyze them. We can still iterate through them quickly because we have references to them. We have pointers to them. All right? Does that make sense? Okay. That's plenty of time with pointers, I think.
They point to things.
They point to things. Takes a full semester to explain this to computer science students, and they get it in like half an hour.
They'll forget it. by
They'll
this
forget
time.
it.
Don't worry.
As long as you give us the terms, we can look it up.
That's right.
Like
Okay.
Haters and Sarah's reporters.
All right. The next thing I want to talk about briefly, and then we're going to see it in an example, okay, is visibility. This is a friend of scope. All right. Now, we all know that by now, I hope you know, that when you have a class, if we, let's say this class has an initializer, I'm not going to spell that out, but in here we set some variable, I like name, well, I guess it's because it's easy. I set it to no. That's descriptive. All right. If I make a new P, all right, if I say we want to make a first person, So we instantiate a person object. We know now its name is node. Right? Okay? We know that anywhere inside of its methods, it can get its own name by using @name. Right? We know we can write getters and setters for that to retrieve and set it. Correct? Okay. Why can't I access name directly? Why can't I just say first.name?
Because you gotta refer to the object.
This is the object. That's the pointer, remember?
I was thinking self.
It's not a method.
It's not a method.
Yeah.
Okay? It's a variable, right? Variables are not visible outside of the context of an object, okay? Unless they're constants. Talk about constants later. But this is a rule that applies to variables. They have a specific level of visibility, and there are 3 levels of visibility within a class. Okay? We'll circle back to this one. We're going to talk about the other type now. If I had something, let me start over. If I had a method on class P, set name, okay? That's my interface with that object, right? We'll say that's the only method I have. Not a very useful person, but okay. But that's the only thing I could do to that object. I couldn't even get the name back. Okay? That's not very helpful, but it is the interface. Let's think of something. Let's use our spy example. Okay? So let's say we had a class spy here instead of a person. Now spy has a name. Maybe it inherits from person, just like before. Okay. Let's say I gave it a method called spy. I could give it an argument for a person to spy on. Now that's more useful, you know, that speaks to some business logic. That speaks to something the class probably actually does. Alright? Now, that sounds like a pretty complicated set of business rules I'm about to have to implement. Right? There's probably a lot of if statements. There might be some looping. There might be some infinite looping, follow this person until, you know, that kind of thing. So, I'm going to specify that it's target. Okay? Something happens in here. Set name, get name, spy, those are all methods that I can access. I can't do that one, so I'll put an X through it. I can say spy if I knew a spy instead of a person, right? So, I need to do this a target. I'll just generate a new person and pass it in as a parameter. Okay? So that's my target. Interfaces speak to what an object can do. They're how objects interact. But sometimes methods like our spy method can be so convoluted and so long because they're doing something really complex, we need to refactor them. We'll show a couple of examples of that here when I go to talk about it. But maybe there's some of that logic that can be taken out to reduce the complexity of that method. Methods that you can make to call from other methods. Some of you did that in some of your homework when we've been talking about getters and setters. Like in an initialize method, maybe instead of setting @name equal to something, you did set name, which worked just the same way. But you can call methods from other methods. So you can isolate repeatable bits of code or complex bits of code to simplify what you're looking at. But just because it's a method doesn't necessarily mean we want to share it with the outside world, right? There might be some methods that do things specifically for you to help you with your logic for cleanup that aren't useful to other objects to be able to call, right? So we have something to deal with that. We have private visibility. Now, inside of a class, if you see the word private, any methods defined below that line are not going to be visible to any objects trying to use them. Okay? They're methods that can only be called inside of the instance, just like our variables. Okay? So if I made one called, let's say, if I have a spy, I wanted them to be able to spy on a target. I didn't care how they had to do it. I just wanted them to spy on it. Well, one of the methods they used was, God, this is going to get bad, stalk. Okay? Well, I don't want people to use the stalk method. I want to use that internally. I just have a lot of logic encapsulated here. And I call stalk somewhere in here. Okay? Alright? Now, I don't want to expose this guy because maybe that only does or solves half of a problem. Alright? I can call it here, but I can't call it here. Yeah, C, right? So, if I try calling it here, I would actually get a no method error. Even though the method exists, it's private. Private methods are only accessible inside of the instance they exist in, inside of the class they exist in. Alright? So, what does that tell you that the rest of the methods are?
Public.
Public. That's your second level of visibility. Your spy method is public, your get name method, your methods that you do for your homework, get description, set description, all those are all public. Okay? Anything below this private would be private and only in this class. Now, there is a third level of visibility.
We're going even deeper.
We're going deeper. This is the weird one. Just want to make sure you have firm understanding of this.
This content not going to be very video friendly.
It's not. This visibility is called protected. Alright? It is what your variables are. Your variables are not private. Your instance variables are protected. What protected means is that any class outside of your class, trying to use it from here for instance, cannot see it. So if instead of making stalk private, I made it protected, I still couldn't use it over here. Well, that went well.
Can you write
Even
this
if you
down,
in-
David?
Yeah, sure.
Even if you inherited spy,
Now, I'm just talking about interacting with the objects. I'm not talking about inheritance.
okay.
Yeah, I'm about to. So I'm glad you went that way, but not yet.
Okay.
So, protected visibility means that if I try to call stalk from outside of the object, can't do it. It's not visible, right? It's just like it was private. The difference is, if I made another class called super spy, and it inherited from spy, it can see all the protected methods. Just like it can see all the variables that it inherits. Okay? So, protected methods respect inheritance. They can be used by classes that inherit from a base class. Private methods, though, do not. Private methods, if I were to leave this private, stock was a private method, the super spy class that we made would not be able to see it. They would not be able to use it even in tournament. Okay? Now, you won't be using a lot of these visibilities for now. When we get into Rails, you're going to be using them a lot.
We're not in Rails yet?
Huh?
We're not in Rails yet?
Oh no. We're still in Ruby. We'll be a while before we're in Rails.
Without going too in depth, you said obviously to run some stuff to help behind the scenes, but is that also, say, for instance, when you get a social security number and then boom, that's it, it's the one time, you know what I mean, like depending on your, that's not the so.
No, this has nothing to do with security. This is design.
Just design, okay.
So it sounds like visibility is a way to control inheritance within.
It's a way to not really control inheritance, to control object interactions. Protected used to not exist. It used to be just public and private. Well, the more inheritance started to get used, they're kind of, well, we kind of need this loophole. We want these private methods that nobody else can use, but my child classes, my subclasses, they need them. So they introduced protected.
And all variables are deemed.
All variables in Ruby are protected by default.
So if you made protected was private and you made a new spy object, would it have the private? No.
Nope.
Can we have a bathroom break?
No.
Okay.
Yeah, probably so.
Yeah, it's that time.
Yeah, I think so.